Hello, this is Yang. My team members Augustine and Kajaya will show implementing infrastructure as code with Ansible through this video. If I explain briefly, infrastructure as code, or IaC, is a methodology for managing and provisioning computing infrastructure. And Ansible is an open-source automation tool for implementing the IaC concept. The reason why we chose this topic for the project is that it provides practical experience with Ansible, which is commonly used in IT environments. Employers highly value this hands-on experience, which can give us a competitive edge in the job market. Our objectives for the project are to enhance knowledge of Linux concepts, improve problem-solving skills through troubleshooting while implementing IaC with Ansible, and also develop collaborative skills. Here's what we'll show you in this video. For my part, I will provide an overview of the technical aspects of implementing IaC with Ansible. IaC manages IT infrastructure using machine-readable definition files rather than manual processes or interactive configuration tools. It allows for the rapid scaling of infrastructure resources in order to meet changing demands. Automation tools for implementing IaC, such as Ansible, Terraform, Chef, or Puppet, interpret the infrastructure code and execute the necessary actions to bring the actual infrastructure into the defined state. Ansible is a simple IT automation platform that does not require agents to be installed on remote systems. It offers different benefits, including efficient provisioning, consistent configuration management, automated deployment, and scalable orchestration, making it a valuable practice for modern IT operations. So let's see how Ansible works technically for implementing the infrastructure as code methodology. Let's assume we have multiple systems. The first system is called the controller, where we install Ansible and create the Ansible files such as inventory files, which have a list of hosts where the Ansible modules need to be run, and also playbooks, which refer to lists of tasks that automatically execute for your specified inventory or groups of hosts, such as managing files, installing packages, or configuring services. The other systems, called the hosts, will be controlled by a single controller system. We do not have to install Ansible on the host systems because Ansible is agentless. That means we only need SSH connectivity between the controller and the hosts without installing Ansible on each target host. So next, we are going to be showcasing a live demonstration of this technical process.
Hello, my name is Augustine Nguyen. We will be demonstrating some basics about how to use Ansible. This demo will show how to install Ansible, how to create an inventory file, and also a basic configuration file for Ansible, how to use an ad hoc command, and how to use a basic playbook. This demo assumes that the SSH daemon is already running on the managed nodes and that SSH key pairs have been set up for Ansible to connect to them. For this demonstration, the left terminal split is connected to an Arch Linux droplet and will serve as the control node. The top right and bottom right are Arch and Debian servers respectively, and these serve as the managed nodes. Normally these would not have to be accessed directly, but are shown here for demo purposes. First, we are going to install Ansible. Since we've recently performed a system update in the background here, we can go straight into installing Ansible with sudo pacman -S Ansible. You would proceed with installation, however here we already have Ansible installed, so we're going to hit no. Once you have Ansible installed, you can type in Ansible -- version to see that Ansible is installed and display the version installed. Once we have Ansible installed, we will need to create an inventory file. I will show ours here. We have named our inventory file hosts and placed it in the project root. This shows the IP addresses of our two managed servers and that they are grouped into two groups, Arch and Debian. These can be grouped together, these IPs can be ungrouped, or whatever makes sense for your workflow. The group names could be anything else, such as web servers or DB servers as well. Next, I am going to show you our Ansible config file, also placed in our project root. This shows the defaults that Ansible will use when running ad hoc commands or playbooks. This lists the default inventory file, so the other file I just showed you, the SSH key location, and the remote temp location. Next, let's run our first ad hoc command. We will copy a file from this control node over to our two managed nodes, Project Arch and Project Debian. First, let's go over to them and ls in the home directory to see that they are empty. And then we will run Ansible, all to specify that we want to run this ad hoc command against all hosts, -m to specify the module. So we have the copy module, which requires two arguments, which we need -a for, src for the location or file name that we want to copy over. So demo's just in the project root here as well. And then the destination argument, where on the hosts we want to copy the file to. So I'm just going to copy over to the home directory. Okay, that looks successful. It says changed for both hosts. Let's go over to Project Arch, ls, see that demo is there, and we can also cat to see the contents. Same thing on Project Debian. It should show the same thing. ls and then cat demo. Great. And then next, let's run a playbook. This playbook will install Apache and inetutils and start the Apache server. I'm just going to show you the playbook here, which we've placed in playbooks directory. So this is just a YAML file for our playbook to install Apache on all hosts, also to install inetutils. The line hosts specifies that we want to run this against all hosts. Become tells Ansible that we want to run this as sudo, as we will need to do that to install packages. And then we have a list of 6 tasks, 3 for Arch distribution hosts and 3 for Debian or Ubuntu. Since they use different package managers or Ansible modules, and they also have different names for the Apache service. Okay, let's quit out of that. Let's clear this terminal as well. Go over to Project Arch. Use systemctl to show that we do not have Apache installed, so systemctl status. And it's called httpd on Arch. Could not be found since it's not installed. And then same idea down here on Project Debian. Systemctl status, and it's called Apache 2 on Debian and Ubuntu distributions. Could not be found. Great. So now let's install and run that playbook for both. To do that, we will need to type in Ansible-playbook, specify the location of the playbook. So I have it in playbooks/install start Apache inetutils.yaml. So that's going to run. You'll see some OK messages, but also some skipping messages. Skipping just means that we're not going to use apt on Arch Linux hosts and not use pacman on Debian or Ubuntu, and not start the HTTPD service on Debian, and then we'll also not start the Apache 2 service on Arch because that doesn't make sense. Okay, that's run. And then we can move over to Project Arch to see that it is now active and running. Project Debian also has the Apache HTTP service active and running. And that concludes our demonstration.
All right, hello, my name is Kazaya, and I'm going to be talking about summarizing some key findings we found, discussing the implications of the project, and proposing some potential extensions or future research directions. Okay, so let's start off with some key findings on infrastructure as code. So infrastructure as code helps to provision, manage any computing infrastructure with configuration files. IaC is often also used for its automation, consistency, and scalability capacities. So in automation, it helps to reduce manual work and any human errors. So you don't have to manually go to each host and install or configure the system, which can be tedious and takes up a lot of time. You also probably don't want to configure 50 different servers manually. IaC configurations are also consistent across different environments, and they also have scalability to meet the high demands and allow for rapid scaling of infrastructure resources. So from the different tools for implementing IaC, Ansible was one of our first choices. Not only is it open source and developed by Red Hat, it is also a simple platform that requires no agents to install on the remote systems, meaning we don't need to install any software on our host devices. Instead, Ansible uses the SSH protocol to communicate to the hosts, so you only need to install the Ansible package into your control node. Ansible is also really great for its efficient provisioning, consistent configuration management, automated deployment, and scalable orchestration. All right, so in our playbook, we had something just like this. So it is very simple and easy. Now you can also specify if you can run using sudo by having this line over here become :yes, so that you can run these in sudo. Also, as each distribution has its own package manager, Arch Linux with pacman, Debian Ubuntu with apt, you can specify the tasks to run using the when conditional. So when the host is either Debian or Ubuntu, it's going to use the apt package manager to install the Apache 2 package. So the same thing with Arch Linux, it's going to be using pacman to install Apache. So the state over here is to specify the version that it's going to be downloaded as, which is going to be in the latest version, and you can also use it to start a service. So playbooks are not limited to just installing packages. You can also start services like in our demo when we start Apache 2 and the HTTPD service. So now let's talk about our implications of our project. So one of the things that really helped with the project is to develop our knowledge in Ansible and IaC. It also really helped with fundamental knowledge for managing IT infrastructure. It also really helped with configurations for different distributions. Another implication of our project is automation and application deployments, and being able to automate and deploy configurations that you like to different hosts opens up a door to automate basically anything that you can think of. Now, Ansible is a great tool for automation. So one idea to pursue is creating a playbook which sets up a new system, either Linux or Windows, with the specific configurations that the user would like. Now, a potential research direction is to be able to use Ansible on Windows as a control node. Currently, you can only manage Windows hosts, but not use it as a control node, since Ansible can only run on systems that have Python installed, which includes Linux distributions, Mac OS, and etc. The only exception is Windows, and I think it would be great to use Windows as a control node instead of having to depend on WSL or Windows Subsystem for Linux, Linux distributions, or Mac OS.